Hello, I'm Sonic. We will learn about formulation of linear constraints. You have learned everything about the general constraint, its shaded part, and its feasible region. Now, let us denote an optimal variable as z is the 26th letter said to be Zulu. Generally, we write as follows. Maximize, or minimize z equals ax plus by, subject to the given constraint, say px plus qy, can be either less than or equal to c, or greater than or equal to c, or simply equal to c. And the non-negative quantities are given by x and y are always greater than or equal to 0. One which is called an iso-profit line, according to the optimal solution, which is parallel to the next line, like L1 is parallel to L2. As you know about profit, like Shadow the Hedgehog can find out for the business in marketing. Let's consider the application, the question we are about to say. In a Sega workshop, many members of the workers make mascot costumes. One with Sonic the Hedgehog costume, and other with Amy Rose costume. Say costume A and B respectively. The workshop requires two operations, manufacturing and finishing of costume. Costume A, Sonic the Hedgehog, requires 7 hours of manufacturing, and 2 hours of finishing. And costume B, Amy Rose, requires 8 hours of manufacturing, and 4 hours of finishing. In a month, available hours of manufacturing is up to 500 hours, and finishing is up to 600 hours. The workers estimate that they can sell up to maximum $299 of costume A, and $249 of costume B. Now, formulate this as a linear programming. The objective function is first written as follows. Maximize z equals 299x plus 249y. Then, subjected to the given constraints. 7x plus 8y less than or equal to 500. And 2x plus 4y less than or equal to 600. Where x and y are non-negative quantities that are always greater than or equal to 0. So you can plot them on the graph, as discussed in the previous video. To find the optimal value, such as the point of intersection. By the elimination method or the Cramer's rule, we get x equals minus 700 by 3, and y equals 800 by 3. The optimal value becomes $136,400 for the maximum profit. On the other hand, let us consider the minimum profit. Here's the second question. In an animation technology, the artists make 2 characters of Sonic X and 2 various characters in Sonic Boom. Also, the animators make 4 various characters of Sonic X and 5 various characters in Sonic Boom. Each studio requires 150 hours of minimum time in artistry, and 130 hours of minimum time in animation. Later, each episode Sonic X is sold at least $6.99, and Sonic Boom is sold at least $13.99. Formulate as a linear programming problem minimizing the total cost. Like we did about maximize in the previous question, now we can write as follows. Minimize z equals 6.99x, plus 13.99y. Then subject to the given constraints, 2x plus 2y is greater than or equal to 150. And 4x plus 5y is greater than or equal to 130. X and y non-negative quantities that are greater than or equal to 0. If you solve this, you'll get an optimal solution for the point of intersection. That is x equals 245, and y equals minus 170. The optimal value z is equal to $2,400 for minimum cost. So now, you are familiar with maximize and minimize profit by the formulation of linear constraints. Like, comment, and subscribe now on YouTube.